Hello good day viewers. Remember that this was the problem we solved yesterday, which is x to the power of 4 equal to -4, and I promised to solve the same problem using Demoivres theorem. Alright, let's get started. Alright, here is the problem: x to the power of 4 equal to -4. -4 can be written as a complex number because in general, we have z equal to a plus bi, for which a here is the real part and bi is the imaginary part. So if you observe, we have -4, which is a real number, which implies that the imaginary part is absent or is equal to 0. So we can write this as x to the power of 4 equal to -4 plus 0i. And also you should remember that every complex number can be written in a polar form. And how is the polar form? The polar form of any complex number: z equal to r, which is the modulus, multiplied by cosine of theta, that is the angle subtended by that complex number, plus I sine theta. So how can we transform this into this? Let's do that. Suppose we have the imaginary axis and the real axis like this. How can we construct -4 plus 0i? -4 is on x-axis, so we move to the left 4 units. This is -4, for example. And you should know that it will lie on x-axis because the imaginary part is 0. So we have just a straight line 4 units to the left from the origin. And if you observe, we have an angle from the standard position down here, which is 180 degrees. We can simply call it pi in radians. So you can see that the distance from origin to this is just 4, and that's our r. Therefore, our r is equal to 4, and the angle formed or subtended is what? Pi. All we have to do is to substitute them back here. Remember that z here is the same thing as x to the power of 4. Therefore, x to the power of 4 is equal to r, which is 4, multiplied by cosine of the angle subtended, which is pi, minus, plus I sine the same angle, pi. But remember, we are looking for x. So how can we undo this power of 4? You can do that by multiplying this by 1 divided by 4. We equally have to do the same thing to the right hand side, raised to the power of 1 divided by 4. So to the left hand side, we have only x. And remember to add plus or minus because this is an even exponent. So what you should remember is what? Demoivres theorem. It stated that if you have a complex number in the form of r cosine theta plus I sine theta raised to the power of n, suppose this is raised to the power of n, this can be written as r raised to the power of n multiplied by cosine of theta multiplied by that power. So we have n theta here, then plus I sine of n theta again. So this is what we have. Therefore, this can now be written as 4 raised to the power of 1 divided by 4. Then inside, if you multiply the angles by 1 divided by 4, you're going to get pi divided by 4. So we have cosine of pi divided by 4 plus I sine of pi divided by 4. X therefore equal to 4 raised to the power of 1 divided by 4 is the same thing as square root of 2, because 4 raised to the power of 1 divided by 4 is the same thing as 4th root of 4. And you know that 4 can be written as 2 times 2, and 4 can also be written as 2 squared. Therefore, 2 here will cancel one of the 2's here, and this is equal to second root of 2, which is the same thing as square root of 2. Then multiplied by what is cosine of pi divided by 4 is nothing but root 2 divided by 2, plus this is also root 2 divided by 2 multiplied by I, so we have root 2 divided by 2i. Don't forget the plus or minus. So the next thing we're going to do here is to distribute, because you can see we have plus or minus. So x could either be equal to plus root 2 multiply by root 2 divided by 2 plus root 2 divided by 2i. This is one of the solutions. Then the other one, x equal to minus root 2 multiply by root 2 divided by 2 plus root 2 divided by 2i. So these are the two solutions we have. Let's simplify them. The first one, if you take this, you multiply by this, you're going to obtain 1. So x equal to 1 plus. If you take this again, you multiply by this, you're going to obtain 1 times I is I. So we have 1 plus I. Then the second one, x equal to, you take this, you multiply by this, you're going to obtain negative 1. We have negative 1. Then minus plus is minus again. This time this will give us 1 times I is I. So we have minus I. But remember also, whenever you have a complex number as a solution, its conjugate will also be a solution. So here we have O x equal to 1 minus I. Here also x equal to minus 1 plus I. This is a conjugate of this. Likewise, this and this, they are said to be the conjugate of each other. And hence, these are the solutions to this problem. We have 4 complex numbers, and you should expect 4 solutions because the power of our variable is what? 4. Therefore, we should expect 4 solutions. Tomorrow also, I'm going to show you another different way to solve this problem. Thank you for watching. Do share to your learning colleagues. And don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.